Disease can be caused by infectious or non-infectious factors. Much of these two screencasts are going to be concerned with infectious diseases caused by pathogens or microbes. The term microbes includes bacteria, viruses, all sorts of small single-celled organisms called protozoans, and may also include worms as well. It's worth noting that an infectious condition can also trigger a non-infectious disease. We call these autoimmune diseases. In simple terms, there are two wings to our immune systems. Modern science terms them the innate and the adaptive responses. The innate response is permanently in place. In the old days, it used to be called the first line of defence, or non-specific defences, and it was believed to be related purely to physical barriers. Those physical barriers are skin, stomach acids, hairs and mucus that line the respiratory system, and also substances such as tears and earwax. However, we now know that part of the innate system also involves sophisticated white blood cells or leukocytes. The most numerous of these are called neutrophils. How about the adaptive system? The adaptive system produces a highly specific, targeted attack on a particular microbe or pathogen. It may take longer to develop, several days, but once developed, the memory is stored by the immune system and immunity may well last a lifetime. But yet again, the more we come to find out about the immune system, we've now discovered that the innate and adaptive systems work closely together by signalling to each other. So, innate responses may result in specialized antigen-presenting cells passing information to the B lymphocytes or even T lymphocytes. And also chemicals called complements may be involved, and they promote an adaptive response. Likewise, the adaptive response of T cells and B cells, especially T helper cells, may well result in the innate responses being primed up and actually becoming much more effective and reacting even more quickly than they do normally. We're going to finish this screencast by looking at an innate response. It's the inflammation response. Inflammation can be sudden onset or acute, maybe due to a wound or infection, or it could be long-lasting or chronic, maybe due to an autoimmune response. We're just going to look at acute onset due to a wound. Let's imagine that you're out in the garden and you sustain a wound. You get something in your skin and bacteria enter. The entry of the bacteria activates special immune cells in the skin layers called mast cells, and mast cells are very effective at producing a substance called histamine. Histamine has the effect of promoting blood flow to the site of the wound and also making capillaries leaky. So it becomes easier for neutrophils to leave the blood supply and become attracted to the bacteria by the chemical messages given off by the bacteria, a process called chemotaxis. Once the neutrophils reach the bacteria, they engulf them and then destroy them, a process called phagocytosis. But in reality, those neutrophils can't swim, and they're actually being swept rapidly around the body in the circulatory system. So they're in danger of being continually swept past the wound site. How on earth do they stop and get out of the blood supply to the bacteria? It's rather clever. This is a picture of a neutrophil being swept along, and it's in the rolling stage. It's being rolled along the cells making up the endothelium of the blood vessel. The blue markers, by the way, represent special proteins on the wall of the neutrophil, or the membrane of the neutrophil, and the membranes of the endothelial cells making up the blood supply. They're special proteins. And the wound results in those proteins becoming activated. And when they become activated, they actually become attracted together, and something called adhesion happens. They become sticky. And the effect of that is to slow the rolling progress of the neutrophil down, and that also results in the neutrophil beginning to flatten. Once the neutrophil has slowed right down, then they're able to ooze through the opened up spaces between the cells making up the blood vessel wall. It's a process called diapedesis. And once out of the blood supply, they're then attracted to the bacteria, shown as little green capsule-shaped things, and they engulf them and destroy them by phagocytosis. Notice, by the way, the black squiggle. The black squiggle represents the rather oddly shaped nucleus of neutrophils. The majority of cells in the body have a spherical, or at least disc-shaped, nucleus. Neutrophils have something rather like a string of sausages. And whereas you can't flatten a sphere or a disc, you can stretch out a string of sausages. And that's what enables neutrophils to squeeze through those tiny gaps in a very flexible fashion and head towards the bacteria.